We're starting with a quick review of yesterday's material, which was graphing ellipses. So what can you tell based on this equation? Okay, I heard A is on the Y. What is the value for A? 9, because this is A squared, right? So A is 9 and it's with Y. And we know it's the 81 is A squared because in an ellipse, A is the bigger one, right? All right, and then B has to be 5 and it's paired up with X. So we can go to our graph, go 9 in the Y direction, 5 in the X direction, and we have our vertices and our covertices. Yes? So if I need coordinates for those, what would you tell me? For vertices, what are the ordered pairs? Yeah, and we said yesterday that we could shorten that and just write it as one ordered pair, even though it really represents 2 points, right? Today we are going to be shifting these ellipses off of having the center at the origin, so that's not going to be the case anymore. We'll have 2 separate points, okay? Covertices, what do we get? Laura, what did you get for covertices? Okay, and then the other thing they've asked us for is to figure out where the foci are. So how do we find C in an ellipse? Okay, so C squared equals A squared minus B squared. So if we want to find C, we would have to square root that answer. Yes? So for our example, we said A squared was 81 and B squared was 25. So what's 81 minus 25? Okay, so we have the square root of 56. Okay, what is the square root of 56? Okay, around 7.5. So on our graph, we'd have a focus about there. Yes? So my coordinates for the focus, or the foci, plural, would be 0 plus minus root 56. We good with that? All right, and then you connected your dots, yes? And made a nice pretty ellipse. Okay, questions on that? All right, if I said to define A, B, and C, could you do it? How do we define A? A is distance from, you just used it to graph it. A is the distance from the center point to a vertex, yes? B is the distance from a center to covertex. C is the distance from center to a focus, yes? So what's changing today is the center's not 0, 0. But if you have a dot placed somewhere on your coordinate grid, can you measure A units from it and B units from it? Okay? So, slight change from what we did yesterday. Our 2 equations. It's there somewhere. Almost identical to what we had yesterday, except instead of x squared, we have x minus h quantity squared. Instead of y squared, we have y minus k quantity squared. Kind of like the circle equation that we were using. All right, I'm just going to pause the video, let you have a chance to write this stuff down. Difference now is that instead of the center being 0, 0, we have shifted it to HK. So make sure you have this written down. Center here will be that point HK. A indicates the longer axis, B is the shorter one, same as we had before. And our formula for finding that foci is still c squared equals a squared minus b squared. So c is just the square root of that. Okay. So the first thing you want to do is figure out where is your center, because we're going to build our ellipse from there. So based on our equation here, x minus 1 quantity squared over 4, what would h be? H would be the 1, yep. So our center is going to be 1, what? Y plus 2? Yeah, k is actually going to be negative 2. Okay. So go ahead and plot that on our grid. Okay, that's going to be our center point. How about A and B? A has to be 3 and it's paired up with Y, and B is 2 and it's paired up with X. Okay, so what you're going to do on your graph is you're going to go 3 in the Y direction from that new center. Okay, so from my point here, I'm going to go 3 in our Y direction and label those V for vertices. What are the coordinates of those points? Now we can't just do 0 plus minus something because we're not starting from 0. All right, we have to start from here. So what are the new coordinates? Top one is 1, 1. What's the other one? Okay. All right. Covertices. We're going to go 2 units for B here. We're going to go 2 units in our X direction from our center point. Oops. And those are going to be our covertices. All right. So what are the coordinates of my covertices? On the left, what do we have? Okay. And then on the right, 3, negative 2. Okay. All right. So we have enough to draw it. But we do need to identify the foci. They've asked us to locate those. So how do we find C again? How do we find C? Okay, square root of that. A squared minus B squared. Well, A squared was 9, B squared was 4. So C is going to be the square root of 9 minus 4, or the square root of 5. Now, here's where it gets a little bit trickier, labeling the foci. Because we want to go the square root of 5 from the center, right? We want to add to it, we want to subtract it, or go in the opposite direction. What is the square root of 5 as a decimal? 2.2. Okay, so we're going to go to find the foci from the center point. We're going to go to about 2.2 squares. Okay, so there would be a focus. And then going the other direction about 2.2 squares, there's my other focus. Okay. Now, how I'm going to label that for my ordered pairs. I want to go back to having the square root of 5 in there. I don't want the rounded decimal. So, looking at the two foci, they have an x coordinate of 1. Yes? It's the y coordinate that changes. So my x coordinate would be 1. My y coordinate is going to be from my center point, which has a y coordinate of negative 2. From that negative 2, I'm going to add root 5, and I'm going to subtract root 5 to move down there. So I'm going to write it as negative 2 plus minus root 5. That's going to give me the exact answer versus a rounded decimal. Okay? So because the foci were moving in a y direction, it's the y coordinate of my center that's changing. Okay? All right, let's try another one. We need to find the center. What is my center point going to be? Okay, I heard 3, -1. Agree? Okay, so let's plot that point. And then let's find our A and B. What is my A value? Everybody, nice and loud. A is 5 and it's with X. B is 4 and it's with Y. Okay, so go ahead and get that part of your graph done. We're going to go 5 in the X direction, 4 in the Y direction. Okay, so what are the coordinates of my vertices? Let's do the one on the left here. What's the coordinate of this point? Okay, -2, -1. And our other point over here? What's our other point? 8, -1? Yes? Okay, covertices. Over 3, up 3. And over 3, down -5. Yes? Okay, let's find our focus. So C is going to be the square root of 25 minus 16. 25 minus 16 is 9, square root is 3. So this one works out a little nicer because it's a nice even answer, not a square root rounded decimal. So we want to go 3 in the same direction that we did for the vertices. From our center point, 3 spaces. All right, so coordinates for that, we have 0, -1, and we have 6, -1. Okay, now keep in mind, anytime you're trying to find the coordinates, you're starting with your center point, and you're adding and subtracting your A, B's, and C's, right? So from my center point of 3, -1, I moved in an X direction to find those foci. So if I added and subtracted my C value, I'm getting 0 and 6, right? So whether it's a whole number that I can actually add and subtract easily or it's a radical, it's the same concept. All right. Questions on either of those two? All right, I'm going to pause the video and have you guys try the next one on your own. Looking at this next one, keep in mind that if it's an ellipse, it has to equal 1 on the end, right? So I walked around and saw a lot of people saying, well, do we just divide everything by 9? Well, you can try that. What happens if we do that? We get x minus 1 quantity squared divided by 9. We get y minus 4 quantity squared divided by 9 equaling a 1, right? So we've made it look like an elliptical equation. But what are your A's and B's? If A and B are both 3, it's not an oval shape, it's a circle. Yes? So if you recognize the original problem as x minus h squared plus y minus k squared equaling an r squared, you could go right to saying it's a circle. Okay? So it is a circle. Where is the center of my circle? 1, 4. Okay, and radius is 3. All right. Keep in mind that when you get to the test on this chapter, you're going to have all different shapes, right? So it's not that I'm trying to trick you. I'm trying to see if you are paying attention to what is different about a circle versus an ellipse. Okay? All right. Our last question. It says to write an equation for the ellipse that has the following characteristics. Nowhere in here did it say you had to graph it, but I would strongly recommend that you do so. You are going to be able to find the information you need much better if you can see a picture of it. Okay? So it says the endpoints of the major axis are 7, 9, and 7, 3. Well, what do we call the endpoints of the major axis? Those are the vertices, okay? So I'm going to label that a vertex. And then it says the endpoints of the minor axis are 5, 6, and 9, 6. And what do we call those? Covertices. Okay, now, in order to write an equation for the ellipse, it's obviously not centered at the origin. Okay, so we are going to have to figure out our HK, our center point. And we also have to figure out A and B to write our equation. Yes? Can you tell where the center is going to be for this one? Right? If you cut your major axis, minor axis, look where they intersect. That would be your center. So in our case here, it would be that point. Yes? Okay, so what's my center? What are the coordinates? 7, 7, 6? Okay, so I found my H and my K value, and we also need A and B. Now, we said at the beginning of class that A is defined to be the distance from what? From what to the vertex? From center to vertex. So how many spaces do we go from center to vertex? How big is that? 3 spaces. So A has to be 3, and it's paired up with, which direction are we going? We're going in a Y direction, right? Okay. How about B? B is the distance from center to a covertex. Well, how far do we go here? 2. And we're moving in an X direction. So, do we have everything we need to write our equation? Yes. So we are going to start out in the first parenthesis. We put X minus H. Yes? Quantity squared. So X minus our 7 here. In the second one, we put Y minus K. So Y minus 6. And then underneath, we need the A squareds and B squareds. So A squared would be 9, and we said it should be paired up with Y, so we're going to put a 9 under our Y piece. And then B squared would be 4, and it goes under X. Okay? But it's much easier to find that information if you can see a picture of it and count squares versus trying to figure out which points are which. Okay? All right, so assignment, you are going to be doing 34 to 50 evens, and then I want you to read on page 944 and give me 3 examples of what might show up as an ellipse. All right, where in the real world do we see an elliptical type equation? Okay, but it's all in the reading. It's not like you have to do any research. Okay.